I want to start to review some Leetcode problems and prepare myself for an interview, one that I have not done in a couple of years now. And I've done a lot of studying to get these FANG interviews, and I've cracked a few, and by a few I mean one. And I'd like to get back on the saddle. I'd like to get back in the race. And the way that you want to start is start small and build your way back up. And I feel like this problem right here, reverse a linked list, is a perfect problem because it's a very mischievous problem because it's marked easy. But if you truly understand the problem and know how to approach it, it actually is pretty strong fundamentally to understand how to work a linked list, how to reverse a linked list. And I think this gives you a very good mental image and mental fortitude when it comes to depth first search or even recursion, because it kind of gives you an idea of state management, placement. And it's a very simple action, but the way this action is formatted, it can be harder depending on the way you look at it. Because if I say a phrase to you, reverse a linked list, you might immediately think of going backwards. You might immediately think of basically, I have the entire list. Now, how do I go backwards? What is backwards? So let's go into this problem and let's read the problem statement. It's basically what I described, but let's read it. Given the head of a singly linked list, reverse the list and return the reverse list. So for example, if we get a list that says 1, 2, 3, 4, 5, what we want to do is we want to have it return 5, 4, 3, 2, 1. Okay, that makes sense. Now, ideally, whenever you do these algorithms, the idea is to have non-polynomial time. If you can do it in log n time, that's decent. Even better if you can do it in on time or constant time, of course. So let's try to keep that in mind as well, because immediately what I'm thinking is that you could loop through the list, find the last one, and then, how do I go backwards? Well, I could add a field to remember what it came before. You potentially could do that, or maybe you can't. Given the head of a singly linked list, reverse the list, or return the reverse list. I don't think you actually can do that. That actually makes it a little bit harder. If an interviewer would ask you this question and you said, oh, I want to add a field to remember last, and all you can do is just get the last one and go backwards, this actually becomes pretty trivial and pretty easy. And most people would potentially think of it that way, where it basically takes on plus on time, where you go to the last node, get it, and then iterate backwards, where you go last node, previous, last node, previous, last node, previous, until you get the null. And you could do that, and perhaps maybe we'll try to do that, but let's keep going. So that's the example. 1, 2, 3, 4, 5 becomes 5, 4, 3, 2, 1. Example, 1 goes to 2, 2 goes to 1. Can there be duplicates? Can you have, I guess it doesn't really matter. We're looking at this as values of a node in the linked list. So if we had 1, 1, 1, 1, 1, obviously it would be hard to tell what is forward and what is backwards, but what we're interested in is the pointer. And you'll see with this problem, the reason why it's very powerful is because you can actually pretty easily lose the pointer and lose where you are. So it's actually an interesting problem. I like this problem because I think it kind of illustrates very well the way that you approach this and the way you think about this. So let's write down some information, right? Let's say we have a linked list that's 1, 2, 3. We have the head that comes in, and we know that head is 1. You can go to 2, and we can go to 3. But how exactly do you go and basically go to 3 from 2 and 1? Now, if we iterate the list, we're basically going to say that we're at 3, and okay, we're at 3, but we got to 3. How do we get back to 2? There's some mechanism here where you need to figure out how we got back to 2. Now, again, like I mentioned earlier, the first thought of this would be that you just simply, per node, you simply remember what previous is. And that's where this kind of becomes a different type of problem, because we're not really reversing this list. What we're really doing, and this actually makes the problem very easy, but only if you format it this way, is to say that we're keeping track of what is previous, and all of a sudden what is previous is now what is next. So for 1, what's next? What's next for 1 is null. For 2, what's next? What's next for 2 is 1. For 3, what's next? What's next for 3 is 2. And then that ends because you're at the end of the node list. So instead of doing this, where when I used to see this problem, what would confuse me is I would think of going 1, 2, 3, and then you get to 3 and you start to figure out, okay, how do I go back from 3? It'd be easier if we were starting at 3. We kind of have to build our way to 3 And again, you know, you can approach this different ways. You can do what I just said, use a different data structure to hold the previous, and technically that is, you know, that is technically the backwards piece. But if you see what we want is a list node, that basically all it is that it's a reverse linked list. The new head points to 3, then 2, then 1. So the way we can think about this is that we want to, whenever you're using pointers, you want to always respect the head and not change it. So we're actually going to make another list node, and we'll call this current, and we'll equal this null. We want to keep it equal to null, and we'll make another list node. We'll call it previous, and we'll equal that to null too. And what we'll do is this: we'll say, hey, if this is a good thing to do if you're in an interview, is say, hey, let's think about some edge cases. Hey, can head be null? Maybe. I actually didn't really pay attention to see if it could or could not be null. Let's actually see if that is the case. It didn't really say anything. The number of nodes list is range from 0 to 5,000. Node vals between the values of 5,000 negative 5,000. I guess it could be null, right? Isn't that, oh, what? Example 3, input head. Output head. Yeah, so if they give you like basically like an empty list node or null, it basically returns null. So I guess that is a legitimate case here. So if head is equal to null, return null. Or actually, we could make this a little bit more direct to say just return myself. And let's just say that, I mean, let's keep it easy. Let's keep it simple. If head dot, let's see, does it have a next field? Yes, it does. If head dot next equals null, then just return head, because technically there's nothing to reverse. Like one item is just already reversed. You're never going to reverse that. So now we're looking at things that are 2 or larger. So again, what I want to do is I want to kind of iterate over this list, and I want to keep track of the previous nodes. So let's do that. Let's say, hey, I'm going to, and by the way, let me just say this is very important, because what I'm about to say is something that you use for learning, and something that you use to express yourself, and something that you should be not afraid to do in an interview, which is make things more easy to understand and digest, even if it's bloated or verbose, because what I'm about to do is something that necessarily you don't have to do this, but I want to do it. I want to have another list node, right? I want to have another list node, and I want to call it iter. I'm going to call it iter. And all this iter is going to do is iterate through the nodes. So all we're going to do is this. We're going to say, while head does not equal to null, what we're going to do is this. We're going to say, while head is not equal to null, we're going to do iter is equal to head. And basically that's where we are now, where we kind of like push forward a little bit from null to head. Now, technically you don't need iter, because that's basically what current was there being used for, and we might actually just use that. But the reason why I'm making this piece here is because it's important to remember that you don't want to confuse yourself. And we're going to make iter equal to head, actually, and we're going to do iter is not equal to null, because iter is going to be the thing that we iterate over. So let's do that. That's perfectly fine. And again, you could use current. Iter is just here because I thought of it, and I think that as verbose as it is, I think it makes it easier. And you'll see current basically becomes irrelevant, and iter is the only thing we're going to use, but that's fine. So let's say, we'll say, hey, well, iter is not equal to null. Well, you know, I'm actually interested. What is iter's previous value? We know it's head. So what is its previous value? We kind of don't know. So now the question becomes, what is previous? Previous is actually null, right? Previous is null. And what's interesting about this is that you now have nothing. You have null, right? How can you make one, in this case, how can you make its previous null, which it is, once previous is null? How do you do that? How exactly do you do that? Well, the way we can think of this is that one's previous is null, one's next is going to be, or actually, if we reverse it, think about it in reverse terms, what we're going to have is this. We're going to have 3, 2, 1. So when it comes to 1, its previous is going to be null. There's nothing before it. Or actually, there's a different way to think about this. So I'm saying the words previous, I'm saying the words next. Let's say, to make this a little bit more simpler for understanding purposes, things that are left to the number versus things that are to the right of the number. And let's just say that for 3, what is 3's previous or things that's left? 2. For 1, what is things previous or things that are left? It's 2. So you actually get into a scenario where your next becomes your previous. That's basically what's happening here. So you basically say, okay, my next is basically my previous now. How do I do that? How do I express that? Well, the way you express that is that my next is previous. What's another way to say that my next is previous? Well, instead of saying my next is previous, we'll say that my current is going to point to previous. You understand? So 1 is going to point to 2, and then 2 is going to point to 3, and that's basically how we will reverse it. In all reality, I kind of did this a little bit backwards. It's supposed to be that 2 points to 1, and 1 points to nothing. But we're starting this off from 1. So let's say, 1, what do I want 1 to do? I want 1's previous to be 2. And we want to basically get to a point in time where we are, iterating forward and doing this. Now, here's the thing. Everything I just said, I said I want 1's previous to be 2. Do we have a previous field here? We have list node next. We have the actual list node constructor. We have the value, and then we just have the constructor that takes in the value and next. There is no previous field here. So how do we do that? Okay, we basically have a situation here where we need to express a relationship of 1's previous being 2, and that's how we do that. Well, the way that you express that is to say that 2's next is 1. So basically, what came before is actually what's next. So 1's next is null, 2's next is 1, 3's next is 2. So let's just do it backwards. So we're going to make a new list, and this new list is, we'll call it maybe current, or maybe we'll call it new list. We'll call this new list, right? New list is equal to null, right? And I want this new list to have its next field be, have its current field be its next. So for example, 2 points to 1, which came before it. So let's do that. Let's make a new list and have the next point to last. So what is previous? Again, remember previous is null. We could even do this. We could do, we could like move this just so it's like closer together. So it's a little bit easier to just keep in mind that it is null at the beginning. So we'll say that previous is null. And all we're going to do here is we're basically going to say, okay, previous is null. I want this thing, whatever head is, its next will be previous. So remember, we're not going to do head. We're not going to change it. And iter is just here for iterating. We're going to do new list is equal to, and now this is very important. Remember, it gave us a constructor. It gave us this list node constructor is equal to list node. The value is going to be current for iter.val, right? It's iter.val, I think. Yep, iter.val. And then next is going to be previous. So now what did we just do? We just said that we made a new list node. This list node's value is going to be 1 because that's basically where we're starting off. And 1's previous, or 1's next is previous, and previous is null. 1 is pointing at nothing. Interesting. Okay. What do we do now? How do we progress from here? We have a value. We have a next field, which is null. But how do we go backwards? How do we build backwards? And that's a very key word, build backwards. Now, we are going to go and we're going to iterate forward where we have iter is equal to iter.next, which is pretty straightforward. You're basically just going forward, right? What is previous in this scenario? What is previous in this scenario? Previous is that node. That new list node that we just made, that's previous. That now becomes previous. So now we say that previous is equal to that thing we just created. And we could actually call this new node because I feel like saying new list is a little bit misleading. It is going to be a new list, but it is a new node. So now we have a new node, and we'll say previous is equal to new node. So that's simple. So now what is previous? Previous is a node whose value is 1 and its next is null. Okay, fair enough. So let's keep going. Let's go for the second one. Let's go for the second loop iteration. Second loop iteration, iter is not equal to null, where 2, new node is equal to list node iter.val, which is 2, and previous is 1, which points to null. Okay, so far so good. Iter equals iter.next, previous equals no node, go again. Iter does not equal to null, no it's not, it's 3. New node is equal to list node, value of 3, and previous is now 2, which points to 1, which points to null. And at this point, we're done. We pretty much solved the problem, right? If I'm missing anything, I'm missing things, but I believe we solved the problem with this. So let's run this for the test example and see what happens. Let's run that for the test example. Whoops. List node. What did I... Doesn't it have a... I thought I had a constructor. What happened here? Oh, that's right. Too much. Okay, I was gonna say too much C#, but C# uses new too. I don't even know why I forgot the new. Okay, so it looks like everything worked. It looks like the null worked. It looks like the 2 items worked. It looks like case 1 worked. And honestly, I don't see a situation where this is failing. So let's submit it and let's see if we make any mistakes or if anything times out. And we did it. Hey, there we go. We did a really good runtime and it beats 100%. I don't know. Don't pay attention to that. Pay attention to your big O of n and pay attention to your space complexity. So realistically speaking, we did a pretty good job. If I was a little bit more green, I would be very, very tempted to actually do this completely differently, where the space complexity would increase. I think this is the best way to do this problem. The reason why I think this is the best way to do this problem is because you kind of break down the way that you build. How do you create something new that it's new in its own right, but logically is the reverse of something else? Because if I told you reverse a linked list, you might have to think a little bit. But if I told you, hey, I have a list, can you do me a favor? Can you build me a list? And as you go along, every next entry in the list is the previous. Technically, that is reversing the list. And if I had formatted that question differently, it might be easier for you to formulate that. But at the end of the day, it's what you are, the way you think of things. This was easy for me because obviously I've seen this problem before. But to be fair, I did not memorize this. I don't sit here and memorize the lines of code. And I'm not going to sit here and just, remember these things that are just, not deriving something. My brain was working, right? There was a moment there where I added this iter field because I was like, what is current used for? What's going on? I had to vocalize and say, okay, what am I trying to do here? 1 is previous is going to be null, 2's previous is going to be 1, 3's previous is going to be 2. And it wasn't until I kind of stated out loud, hey, 3's next is going to be 2. Oh boy, how do you get to that? See, the hard thing about this is that you're building this list 3, 2, 1 backwards, where you're starting at 1 and you should say, okay, what is 1's previous? Null. Do we have the previous? Yeah, I do actually. Yeah, null is, I can get null. I always know what previous to that is. It's null. And then what's 2's previous? Well, wait a second. I know what 2's previous is because I just created 1. This is this is almost, I don't want to say this is induction, but it's very induction-like, where once you get that first piece of the equation, everything else becomes a lot easier. Because what was the hardest thing? The hardest thing was formulating and vocalizing that, hey, this 1 right here is going to have a previous field of null. And then when we iterate forward, which, iterating forward is fairly straightforward, hey, what should previous now become? It should now become new node because we're kind of going forward. And this is a very strong ideological thing to try to come to terms with. And you might not always see it because obviously I've seen this problem before and I have some familiarity to it, and I didn't memorize it, but my brain has worked on this problem before, and it recognizes the pattern. So this idea of keeping track of the previous is really important, very important. That's why I would actually stress to try to do it this way and make sense of it. Because when you move to problems like sliding window, when you move to problems like knapsack problems, when you move to more dynamic problems, there's this common theme of moving forward, and at the same time of you moving forward, remember where you were. Remember where you were, and where you were is usually where you are, and it's really, you're building the solution. That's why it's called the dynamic programming. You're building the solution as you move forward. But again, it's very important to understand this. I don't just do this because, you know, this is a quote unquote good solution.